Hello, welcome to Salsa classes again. And the question here is correct statements among the following with respect to ionization energy, IE is R. That means there may be more than one. IE1, IE2, IE3 for indium is more than that of aluminium, which will be wrong. Why? Because we know ionization energy decreases as we go down the group and increases as we go along the period. That is the indication that I'm trying to make by writing the arrows in this direction and this direction. IE of scandium is higher than that of cobalt. For that, simply write the electronic configuration. And as you can see over here, scandium is in the left-hand side of the period. Cobalt is on the right-hand side of the period. D electrons have poor shielding effect. So obviously, IE will increase because there will be some amount of contraction happening as we go along the period. And we know at Z, as the contraction increases because of the Z effective increase, so ionization energy also will increase. So scandium will have a lower ionization energy than that of cobalt. For gallium, a similar explanation again, which can depend on the Z effective. Z effective will increase from gallium to selenium, and so we will say that selenium will be having a higher ionization energy than that of gallium. That means gallium will have lower ionization energy than that of selenium, and so this option also is true, okay, because it is saying gallium is lower than that of selenium. IE of nitrogen is greater, should be greater, I missed the E, and then that of oxygen. Why so? This is true. Why so? If you write the electronic configuration of nitrogen and electronic configuration of oxygen, what you can see over here is that nitrogen is having maybe less Z effective than that of oxygen, but here the 2p3 is half filled. That means it is having much more higher exchange energy than that of oxygen. For this simple reason, because the p orbital is half filled and it is not having half filled or completely filled configuration. So this is unstable. It wants to gain stability. How will it gain stability? By losing one electron and going to electronic configuration of nitrogen. So that is one of the destabilizing factors. For here, the stabilizing factor is what? That this is having 3 unpaired electrons in the p, so it is having higher exchange energy. So we will say what? Statement 3 and statement 4 is true over here. Okay. Now in the next question. All right, again, this is something that is directly from Atkins. Okay. The reason for this significantly high solubility of AgClO4 in benzene, then in alkane solvents. So alkanes are not having any pi electrons. Okay, whereas benzene has pi electrons. That should be registering to your mind. Alkane solvents are nonpolar, has no meaning to it. Benzene is aprotic, does not make any meaning to this question. pH Ag is formed. So it is not saying pH Ag plus. Okay, had it said pH Ag plus, then this should have been a correct option. Benzene acts as a salt base, which is true because benzene, because of its pi electrons, okay, can donate its electrons to the Ag plus, and then it can form something like this. As it has said over here, we need to consider how the solvent interacts with the solute. The pi electron of benzene, a soft base, are available for the complex formation with the empty orbitals of the Ag plus cation, which is as a soft acid. Basically, they're using HSAB principle over here. That is Pearson's hard soft acid base principle. So when we say soft acid, that means it is a cation. When we say a soft base, that means it is a something that can give away electron density using pi electrons or lone pair. Okay, Ag plus ion is solvated favorably by benzene. The species, as I was saying, had they given pH Ag plus, rather it should be pH Ag plus, not P. There should be pH capital H Ag plus, okay, but they have only given pH Ag plus. This means this is a phenyl energy, which is wrong. Okay, it is forming AgC6H plus. Okay, C6H6 plus, AgC6H6 plus in the complex of the acid Ag plus with the pi electrons of the weak base benzene. So please understand why this is wrong. Okay, I repeat, it is not pH, capital H Ag plus. Okay, so they are trying to say over here, this is pH minus and Ag plus, and so there is a salt formation, something like that. Okay, so which is untrue. So here the correct option will be benzene acts as a soft base. Okay, I hope that explains the questions that we had over here. Thanks for listening. Keep visiting Saurabh's classes. Okay, have a great day.